Good afternoon and welcome to towards the end of the second day of reInvent. Is everybody's having a good time? Yes. All right. It's only in reInvent I have seen people so excited even at the end of the day. And everybody's looking towards the party, 8 o'clock? All right. My name is Abdul Sattar Said. I'm a solutions architect at AWS specializing in migrating enterprise loads, and I have with me my colleague Tom-Laszewski. We have a lot of stuff to cover today, so I'm not sure if we are going to have enough time for QA at the end. If we get done quickly, then we'll have some QA, or otherwise, after the session is over, I think ours is the last session, we'll just stick around. Anybody who have questions can, come by and ask us questions. When it comes to enterprise migrations, there are multiple ways of going about doing the migrations. And it's very much different from a startup or a web application company migrating to AWS. Because a lot of stuff they have is actually custom-built application that they know how they build it. They can make it work better on AWS. They can make changes as they need. Most of these things are not possible when it comes to many of the enterprise applications, because most of the enterprises buy prepackaged off-the-shelf applications like Oracle eBusiness Suite or SAP, or we are talking about SharePoint or Exchange. So these are all applications built by somebody else, which has some requirements, some needs, some constraints. So moving them to AWS takes a little more planning, a little more phased approach, a step-by-step approach, so it could be comfortable doing what you are doing and will be successful doing what you're doing. One other complexity of enterprise migrations is the whole enterprise is the IT, the application infrastructure of the whole enterprise is like a living organism with a lot of interconnected applications. A lot of applications have many touch points, a lot of integrations with each other. They need to talk to each other. So none of these are isolated applications that you can probably just pick up and move. So that makes it even more complex. So these are the subjects we are going to cover today. We'll look into the total cost of ownership when you move to AWS and how it translates to what you are using it, how you are using it now, how it compares to the cost that you are incurring now and probably you will be incurring when you're doing upgrade and buying new hardware and whatever else. We'll look at some architectures, some simple architectures, high availability, more complex architectures. We'll go deep into some of the preferred architectures and discuss how to implement it. We'll also look into some of the key technologies that every enterprise migration should include and involve. We'll look into migration best practices, tools and services available, as well as towards the end, we'll discuss a very successful customer migration project. And to get things started, Tom-Laszewski.
Thanks, Abdul. So the first thing I want to talk about is a little bit about TCO. So we're all technical folks, but probably the first thing we get asked when we're going to architect a solution is, is this really worth it? Should we really undertake this project? So here are some of the do's that we want to consider. And obviously, AWS came up out of on-demand, right? It's compute, elastic compute. But what I find from an enterprise perspective is that most people lock themselves in, if you will, or pursue a 3-year ROI, or 3-year reserved instance purchase. So I'm talking about 3 to 5 years, because when you're talking about things like SharePoint, eBusiness Suite, SAP, you're probably not going to shut it down. You're probably going to be running it. It's mission critical to your business. You're going to keep it running for a while. So I typically will go out and use a simple monthly calculator and automatically go for 3-year type reserved instance purchase. The other thing you want to keep in mind, obviously, is that storage. Now, when you're on premise, right, you're typically doing your backups probably to standard NAS SAN devices. And when you're moving to AWS, you want to take advantage of S3, obviously, right? So you're going to be using EBS PIOPS. In most cases, you're going to be using PIOPS. Bill will talk a little bit about that. And then you're also going to be using S3 and then Glacier. The other thing to keep in mind, and this is a little bit harder to quantify, is the cost benefits you get from automation. Using things like Chef, Puppet, cloud formations, auto-scaling. You don't typically have auto-scaling type functionality on-premise. And then things that you can use to optimize your infrastructure, such as Trusted Advisor. The don'ts is oftentimes people might forget about the fact that I have a DR site and how much does it cost me to keep my DR site up and running. Also, people forget about the fact that everything that goes into a data center, power, cooling, storage, the network, all the network costs, the cost of keeping the network up and running, the cost of upgrading your network. The big thing, you'll see it on there with now you're moving to our virtualization platform. People that are familiar with running Oracle workloads on-premise, VMware. If you're running virtualization, VMware, and you have a 16-core box, you're only using Oracle on 4 of those cores, you still get charged for 16 cores. So it's something to consider is your cost of your virtualization on-prem as opposed to moving to AWS, what it's going to cost you. Also, don't forget about the fact that in some cases I've actually seen this where people don't actually even have DR. So what's the cost benefit for you to actually have a DR solution now? What's the benefit to you to not have to have another data center where you do multi-AZ? And then the bonus, now these get really, really difficult to quantify, right? And I would consider these to be intangible benefits. They're not concrete, they're not tangible, and it's a hard time putting a dollar amount on them, but you don't want to forget about the cost of the fact that your customers aren't satisfied at a certain point in time, the fact that you can turn your instances down, especially with your development instances during the weekends, or the fact that you could take advantage of something like spot instances to do payroll at the end of the month. So if you're running something like PeopleSoft, you're going to do payroll at the end of the month, you can take advantage of doing spot instances. So how do you quantify all that? How do you determine what the benefit to you? Abdul, is this, yeah. So Abdul's going to talk a little bit about licensing.
So before I get into licensing, this is, whenever we get started talking to enterprises about moving their workloads to AWS, always the first question that comes up is licensing because it's very critical. Everybody pays attention to, the audits and compliance and whatnot and make sure everything they are going to bring into AWS is in compliance with the license they have. Before I go more into the details, can I have some show of hands of how many people are already running some kind of enterprise workloads on AWS? Wow, that's a good number of people. And how many people have either moved or planning to move Microsoft workloads? Great. And how many Oracle workloads? Wow, good number. And how many SAP? Okay. So the reason I'm asking these three are, if you take the enterprise as a segment, most of these enterprises run at least one of these softwares from one of these vendors. So this is where most of the licensing comes down to. And keep in mind, one of the things that you cannot move to AWS is, as such, the kind of platforms that are not supported on AWS, right? Which would be like Solaris or AX. So you need to think about how, when you move those workloads to AWS, how does the license map to the platform that you're going to run on AWS? Because most of the software runs on multiple platforms, and it doesn't matter which platform you run it on, it performs perfectly fine. So when it comes to Microsoft, all the Microsoft licenses that you currently own are transferable to AWS, provided you have the license mobility through software assurance. So software assurance is the kind of like Microsoft maintenance term. So when you have volume licenses with software assurance, all those licenses that you carry can be completely moved over to AWS. There is some paperwork that you need to do. Once you get done, it's all available. The second way of using Microsoft licenses on AWS is buying licenses with your instances itself. So you must have seen when you go to launch a Windows instance, you can see the Windows instance is actually priced differently from a Linux instance. The reason is now that instance price includes the license cost of Windows running on that instance. So there are two ways. So for most of these licenses, you'll see these two ways. One is pay as you go, and the other is bringing your own license. Let's move over to Oracle. Same story. You have pay-as-you-go for certain things, and you have bring your own license for everything else. So pretty much all Oracle products run really, really well on AWS, and all Oracle licenses are fully portable to AWS. This includes your unlimited enterprise license. It includes a partner network license, OPN license. It includes BPO license, which is kind of like the outsourced per-use license, as well as even the trial license like OTN license that you download from eDelivery or oracle.com. And with Oracle, there is pretty much no paperwork to do. It's your responsibility to make sure you are compliant with the licensing terms. So as long as you own the license, you can bring to AWS and run it. And when it comes to pay-as-you-go for Oracle, that's available only for RDS. So for RDS, we provide two options. One, you can pay for Oracle license as well when you run RDS. That's the license included model. That's available for Oracle Standard Edition. Now, if you want anything other than Standard Edition, like Enterprise Edition or Standard Edition 1, or you already own Standard Edition licenses, you can bring those licenses with you, and the cost for RDS will be much less. And when it comes to mapping, Oracle licenses, the database licenses, or anything that depends on number of cores, maps as shown there, 0.25 multiplication factor for standard licenses, and 0.5 multiplication factor for enterprise licenses. This is very similar to how you would license on a physical Intel server. So if you are coming from something else like Solaris-based machine or AIX machine, the mapping is going to be different. So that is something that you need to keep in mind. So for example, if you are going to run your Oracle database on a 16-core instance, EC2 instance on AWS, with the 0.5 multiplication factor, let's say Enterprise Edition, 0.5 multiplication factor, 16 cores into 0.5, that is 8 sockets. That's what Oracle calls sockets for the license, right? So you need to have license for 8 sockets already with you. So if you have, for on-prem, you're using 8 socket licenses, you can bring it, run it on a 16-core box. You need to make sure you are not running this on a 32-core box, then you'll be in violation. And if you're running it on an 8-core box, what it means is you have 8-core license left to spin up another instance, right? Now, if you're going to do the same thing, you're coming from a Solaris-based system or AIX-based system, the multiplication factor there is double. So you might be running on a 4-socket machine on-prem. Now, those 4-socket translates to 16 cores on an Intel platform. So you take that 4 sockets, when you come to AWS, you can use the same thing for 8 sockets on AWS. So there's a mapping table available from Oracle. So pay attention to those things when you do mapping and figure out what exactly you need to pick. Kind of like, in a way, similar for SAP as well, both pay-as-you-go and bring your own license. For SAP, there are a lot more products available for pay-as-you-go. SAP is HANA, which is one of their new products with all-in-memory database, a fantastic product, is available through Marketplace for 99 cents an hour. So you don't need to buy a license for perpetuity. You can just pay for the license for the number of hours that you use. So it's available for business objects as well as trial and development licenses, all available pay-as-you-go. Then if you already own licenses, most of the SAP licenses are actually based on users. You can bring your existing licenses and use that on AWS as well.
Excellent. All right, so let's get into a little bit of architecture here. Before Abdul goes into showing you some architectures, I just want to map, because this is a question we get oftentimes. It's like, I have this stuff on-prem. I'm running firewalls. I'm running IDS, IPS solutions, Trend Micro, Alert Logic, things like that on-premise. What's the equivalent, or how does that map into AWS? So quickly on this, so from a security perspective, we all know security groups are there. So instead of having firewalls on-prem, you're going to be using security groups or NACLs to secure your subnets. In terms of IDS and IPS solutions, a companies like Trend Micro or Alert Logic have AMIs available that you can buy, so you can use those same solutions that you use on-prem. Some other things, obviously database, you can choose to use those and run those on EC2, or like in terms of MySQL, SQL Server, Oracle, you can choose to run those on RDS. You can continue to run MongoDB, CouchDB, and all these NoSQL applications, or you can use DynamoDB. So same thing with load balancers. Obviously, we have our own load balancer, but people are familiar with HA proxy. HA proxy allows you to do reverse proxy, something our load balancer doesn't do. So you have to take a look at some of these solutions and say, well, does it map exactly into what AWS provides? Another limitation sometimes we find with the Elastic Load Balancer is the fact that you can only have one SSL certificate per port on your ELB. So some people choose to say, well, I'm going to run F5 Load Balancer because that's what I ran in-house. You can run F5 Load Balancer on us on an EC2 instance from our marketplace, so that's fine. Another solution might be, well, I have an ELB for each SSL certificate that I have, and I have up to, we have some clients that have up to like 200 ELBs to service the need to have multiple SSL certificates. So here's some more mappings. Some of the stuff that you're probably familiar with are running things like Netezza, Exadata, Teradata on site. You can choose to run that on Redshift now. For archiving, obviously running something like, or using something like Iron Mountain, you could choose to map that into Glacier and not do tapes anymore and do that to Glacier. In terms of LDAP servers, something like Active Directory, right, you can run that on us. One of the questions we get oftentimes is that now I'm still going to have applications. In fact, the case study we're going to show at the end of here, they're running on-prem yet. They're running their Active Directory, but the Active Directory is also running on AWS, so they have to do some synchronization between the two, because I think we all know that IAM does not replace things like Active Directory and LDAP server, because IAM is for the AWS backplane. It's not for the users that are using your application. Things like Chef and Puppet can be used, but we give you the option to use things like CloudFormation or OpsWorks or Beanstalk in order to do automation of your deployments. So you could choose to use things like Chef. In fact, Chef and OpsWorks will integrate and work together. So you could continue to use those or move it completely to OpsWorks. There's also things like if you're running a queuing system on-prem, you can continue to use that, or you can use something like SQS.
So these next 4 slides, I actually intended to make you repeat after me. Because I want you to just get this picture in your mind. You probably know what this is. Anybody who doesn't know what VPC is, raise your hand. I can tell you more about it. So no. Everybody knows VPC. So I just want you to keep this picture in your mind of the next 4 slides, because this is extremely important when it comes to enterprise migration. You don't want to do your migration without using these technologies. And if you are in a position to influence a migration, or you are enterprise architect, or you decide which projects gets rolling, then make sure you ask people if you are using all of these in your migration. So one is VPC. VPC allows you to have your own kind of like network, isolated network, carved out of AWS network. So it is just for you. Nobody else can access it. You can have your own IP addresses, which I see is as a huge advantage over the way we used to do things before. So you can decide what IP addresses you want to use. The only thing you want to make sure is your IP addresses don't overlap with your on-prem IP addresses if you are going to connect the VPC to your own data center. So I see the cloud migration as something that is going to happen over a period of time in bits and pieces, in multiple phases, just because of the nature of enterprises. We are not talking about tiny little applications that you can just lift and shift, right? There are a lot of applications in there. There are a lot of applications that needs a lot of effort to be moved. So some applications will come to cloud, while some others are still on-prem in your own data center, which will come over in the next phase. Now, in the meantime, they need to talk to each other because of integrations. There are a lot of touch points. They need to share data or exchange data. the best way to make this possible is to connect your existing data center, your existing applications, through a VPN connection into VPC. So now you have VPC on AWS side, you have your own network on your side, you use a VPN tunnel to connect these two. So whatever you have on AWS within VPC becomes like an extension of your own network, right? So this is kind of like a hybrid methodology to get started. We'll look into some more details of how you will use VPC and more details into the architecture to compare it to the firewalls and the isolation levels, a little more in details into the future slides. The second thing I want to keep in mind is PIOps. Maybe I should make you repeat it after me. So do not use anything other than PIOps for any workloads. PIOps upfront might look like a little more expensive, but I was surprised many times when I do to simple calculator. I was putting together a bunch of architectures for enterprise application migration to AWS. And for these architectures, I wanted to kind of like, make it simpler for people to understand how much it's going to cost them, get a ballpark number. So I was working on that using our simple calculator. Sometimes I was really surprised, actually, PIOps is cheaper than the standard volumes. Not always, but sometimes. So make sure you use PIOps-based volumes all the time. What PIOps volumes gets you is two things. Consistent performance, which is extremely critical to any enterprise load. You don't want your payroll run to take 2 hours one day and 2 days the next month, right? You want consistency. So for consistent performance at the I/O level, you need PIOps. Provisioned IOPS, you can decide how many IOPS that you want. You can say, I'm going to need 20,000 IOPS, and that's what you're going to get. But to get to that 20,000 IOPS, there's probably a little bit of work that you need to do, because the volumes that we have available today will provide you 4,000 IOPS. So if you want 20,000 IOPS, what you need to do is you need to take 5 of these volumes and stripe them together. So there is something very interesting we did about a month ago. For the IOPS, we had a limitation of a factor of 10 before. That's how it was. So if you are going, the EBS volume that you are getting is 100 gigs in size, the maximum IOPS you can get for that was 1,000, with a factor of 10. About a month ago, we bumped it up to 30 times. So now with a 100 gig volume, you can get 3,000 IOPS, right? So depending on your IOPS requirement and your storage requirement, you take multiple volumes, stripe them together. There are multiple ways of striping. You can, if you're using Oracle database, ASM is a very good way of striping. If you're using a Windows server, you can use Windows on built-in striping capabilities. Or you can use MEDIM or LVL, any of these open source technologies available to stripe to make the whole thing look like a RAID array to your application. So number 1, VPC. Number 2, PIOps. Always use PIOps for everything, for your database volumes, for your file storage, everything that you do. And I don't have that in the slide here. Always keep in mind your instances come with a local storage, or which we call ephemeral storage or instant storage. So this storage is right there in your instance. The bad thing about this storage is if your instance goes away, if you shut down or reboot whatever do to your instance, that storage goes away. Whatever was in it is gone. You cannot get it back. So we recommend people do not use this storage to store any critical data. But remember, this storage is right in your instance, whereas EBS is over the network. So how much ever performance EBS gets you, still the data needs to go over the network to get there. So put your local storage, your ephemeral storage to good use, which would include temporary files or temporary table spaces for your database. Just for whatever you wouldn't mind losing if you shut down the instance, make sure you use the ephemeral storage for it. The third thing is direct connect. So direct connect, again, is, I wouldn't say this is critical. I'd say this is crucial. If you have direct connect is a direct connection between your data center and AWS data centers, right? It gives you a low latency, high bandwidth connection so that all your integrated applications can be, can talk to each other in a very consistent manner, and you can move good amount of data in a small amount of time. So direct connect is the third thing to keep in mind. And the fourth thing is cloud formation. How many people here have used cloud formation? That's impressive. Actually, I was talking to many of our customers and partners. I was under the impression that not a lot of people are using cloud formation. Cloud formation is extremely important for enterprise loads because in enterprise, you have multiple environments for doing the same thing, right? If you have, let's say you have a PeopleSoft environment, you will have a sandbox environment for PeopleSoft. You'll have a patch environment for patch testing. You'll have multiple development environments, unit testing, integration testing, regression testing, UAT, production copy. So 9, 10, 11, 12 environments for doing the same thing, right? And most of these environments are probably going to look similar. So if you use cloud formation for building your first environment, the next time you don't have to do this much work. It's basically just launching your cloud formation. So you have your cloud formation, you launch it, it brings you that one database, 5 application servers, 15 web servers, sets up the ELB, hooks everything up together, and it's like magic, right? Your multiple environments would have different instance sizes. Your development environment might have small instance sizes because it's not going to be much load, but your production environment is going to have larger instance sizes. So the instance sizes and the performance that you will pick will be different, but the overall architecture, the layout is going to be the same. This session is mainly about migrating enterprise applications, but I want to talk a little bit about how most of our customers get there. The first place most of the customers get started with is with archiving and backup. There is so much we provide on the backup and archiving side. It makes all of these much simpler than what you are used to and a whole lot cheaper than what you are currently paying for it, as well as make it easy for you to retrieve data and do whatever else you want to do with it. So normally the way people do backup is you take probably some disk backup for local backup, then you take a tape backup, you send the tape to offsite location using some other provider, and hope when you need it, it'll be available, right? And this includes pretty expensive, in most cases, pretty expensive tape, robot assemblies and whatnot. Whereas if you are using AWS, all these things get simplified. Let's say here is an example with an Oracle database. So that is your on-prem data center, your own corporate data center. You have your Oracle database running there. You have your application servers and web servers running there. Now you want to back up this data into S3. So by the way, this is something that we did ourselves in Amazon.com. Amazon.com with our scale, we'll be producing and using a lot of data. So we used to use tapes as well for our backups. The past year, this was a major project of migrating from using those tape assemblies to using S3 for all our backup. Now all our Oracle databases use S3 for our backup. Things got like our backing up process got 16 times faster, retrieval got 20 times faster, and costs went down so tremendously. And S3 is one of AWS flagship products with 11 nines of durability, right? 11 nines of durability means you probably never lose any data in your lifetime. So that's not just for the database, right? You can use the same thing to back up files to AWS as well. So for database, when it comes to Oracle, Oracle has provided a utility called Oracle Secure Backup Cloud Module. So this works very well with RMAN. It's like a plug-in to RMAN, right? So on your side, nothing really changes. For the Oracle DBA, nothing changes. They use the same RMAN to backup. Earlier, it used to be a plug-in for the tape. Now it's a plug-in for S3. So you use the same tool for backup. The data just ends up in a better place, right? And when you want to retrieve that data, you want to restore, you have nobody to call, wait for the tape, and hope it'll work. It's right there for you, available anytime you want. And for the files, you can use Oracle AWS Storage Gateway. You set up Storage Gateway to automatically back up to S3. Storage Gateway works as kind of like a cache in between as well. So it emulates a C drive. So you can write to the Storage Gateway. Storage Gateway will asynchronously write it back to S3. A lot of other commercial products that enterprise customers use, like Symantec Net Backup or Backup Exec or Commvault, Whitewater, all these things are fully support S3 now as the backup mechanism. So you can, either you contact those vendors. You can get all information about the partner products on our website. Check out if you are using any of those products. Contact your vendors to see if you can reconfigure those products or update them to use S3 as your backup mechanism. This is very near to my heart, disaster recovery side on AWS. In my career of enterprise application implementation, I have worked on a lot of DR sites. What I have seen is DR is something that customers set up only for the most critical systems, right? Because it's expensive. The ROI is low. Because you always hope nothing will go wrong, right? And if nothing goes wrong, actually this doesn't get you anything. If something goes wrong, then it's nice to have DR. So it's kind of like it's a difficult decision to make. How much money would you put into it? Then you think, what if something goes wrong? Or if my business is down for 2 days, that probably is a $20 million loss. So maybe we should put $10 million into it. So normally, most customers do a scaled-down implementation for DR, a 50% scale, 50% of production. So if something goes wrong, you can take, you can perform at a 50% reduced rate compared to your production. So you can still run your business, but it still costs a lot of money, and you're performing at a reduced level. There is so much AWS brings to the table in this space. We have few different architectures. Actually, I'm doing another session on DR exclusively tomorrow morning at 9 o'clock. Because of the nature, the elasticity, the on-demand accessibility of instances, the programmability, the scriptability of the infrastructure, there's so much you can do on AWS when it comes to DR that you could never do anywhere else. People wouldn't even think about it. So this is one of the simple architectures for DR on AWS. What you see on the right-hand side or bottom of the screen is your own data center, the customer data center, where you have your DNS server resolving whatever your application to your application or web server. So you have your application and web server there. You have your database server. Now on the AWS side, where you have your DR side, and again, some customers would have DR side across the street in a building across the street. I wouldn't really call it as a DR site. Most of the time it's a disaster waiting to happen, right? So if you have a flood there, and like what we had in New York, New Jersey, having it across the street is not going to help you. So you want to have it in a remote place, right? Doing it in a different region, it brings its own logical challenges, because you don't probably have any business there. You don't know people there. So it gets even more expensive doing it that way because you don't have business operations there. Whereas with the global footprint of AWS, all these 9 regions all across the world are available to you at your desktop. So you can have your DR site set up in Oregon or in California or in Singapore or Tokyo or Brazil, however you pick. You could even have multiple DR sites, right? So in this case, what we are doing is on the AWS side, you have only the database server running, whereas on-prem, you have the application and web servers running. On AWS side, you just have the database server running, and you are using data guard or whatever replication technology you use. The data is being replicated to the database running on AWS. And we don't have the application servers running. We don't have the web servers running. And there is nothing really happening in that database except synchronizing data with your production server, right? There's no load. You are not using it for anything else. It's just sitting there receiving data. So you don't really need a beefy machine. You need like a tiny little machine, right? So you go with a small instance. We have a small instance receiving data, and then we have created what's called AMIs, which is kind of like a freeze-dried image of an instance for the web servers and app servers. It's all sitting in S3. So when something goes wrong, basically all you have to do is have a bunch of CloudFormation scripts that will switch you over to AWS. From the AMI, set up the application servers and the web server, and then make the database server bigger. This is how it was before, and now you are hit with DR. Your CloudFormation script kicks in. It increases the size of your database server. It brings up application and web server, everything within a small amount of time, and you're back in business. And the amount of money it costs you to set up this DR is very, very, very minimal, especially compared to what you're spending today. The other side of the story is because it is so inexpensive to do this, now you can have DR sites for all kinds of non-extremely critical environment as well, right? So if something goes wrong anywhere in your enterprise, you can switch over to AWS and start working there. So now we talk about the enterprise applications architecture.
All right, so Abdul was talking about archiving DR. This is like actually moving a small system. So you can see here, and the one problem I have with some of the architectures that I oftentimes see is they got everything in them, right? They got auto-scaling ELB, they got multiple AZs. This right here is a minimalistic architecture. And what you're going to find is that, and we've actually implemented these, people using SAP, people using eBusiness Suite, PeopleSoft, where you're not so much concerned about the fact that my system goes down and I need to recover immediately, right? So what we're doing here in this scenario is, Abdul explained the pilot light scenario where you have a database up and running somewhere else. In this scenario, it's strictly cold type scenario, right? So you have a web server, you only have one of them. You have an app server, you only have one of them. And in fact, in some cases, we've actually seen web servers, app servers combined into one. And then you have your database tier, which you probably want to keep that separate. But all you're doing here is you're snapshotting. So you're not using any Oracle software, any Microsoft software, any third-party software that might cost you any money. Because your whole idea behind this architecture is that you want to strip down and have the lowest cost architecture possible, right? So you don't want to have any third-party. And Abdul will show you a bit of an architecture that has like Oracle backup, secure backup, which is going to cost you some money. You don't want that in this scenario. The only thing I caution you on this one is that it's showing you multiple EBS volumes. So you're going to have some striping here. You're going to have a logical volume manager, right? So what you got to be careful of is when you quest those, you got to quest all those. So your database storage does not get messed up. So that's one word of caution on this. A lot of times when we implement these scenarios, they're in very small situations where someone's running, say, a 500 gig database. All they have is one volume. So when you have one volume, you can quest your database, snapshot that volume, and be up very quick. A little bit of a caution when you're running multiple volumes and you're striping those to make sure that you don't you don't just snapshot one of those instances, try to keep the other ones up, try to keep your database up. You're going to have to be very cautious about that. But this is a very low-cost scenario. So then if we scale up, we go to a hot HA. I'm sure a lot of people have seen these architectures. Just a few things I want to point on this because Abdul's going to go into more detail. We've seen these a lot. Just a word of caution when you're running enterprise-level systems on here is that on your app servers, if you have auto-scaling, when you're scaling up and down, say if you're doing connection pooling to that database, you want to make sure before you scale down that any of those connection pools are shut down. Otherwise, you're going to have rogue connections on your database, right? A lot of people aren't concerned about those when they're not running enterprise-level applications, but when you're running enterprise-level applications, you're probably using JDBC connection pooling. So if that instance is going to be shut down, you want to make sure that you gracefully shut down any connections before you auto-scale down, right? Auto-scaling up isn't much of an issue because what you can do is you can have some bootstrapping that will automatically do your connection pooling when you auto-scale up. The other thing to keep in mind, people running Oracle Web Logic, and this is like sort of really seems backwards and seems a little bit outdated, but a lot of people use sticky sessions. So what's going to happen if you're using sticky sessions in a WebLogic cluster? Well, what's going to happen is that someone might have their session on one of these instances that might get auto-scaled down. So if you auto-scale way up, you don't know where that session is, right? So you're going to have to be careful about using auto-scaling in a WebLogic scenario or any type of scenario where you're using sticky sessions, or you have some kind of sessions persistent that your client is relying on to be there, and then you're going to auto-scale down. So just a couple of points on that. In this case, and Abdul's going to go more into like replication, how you'd use like Oracle type backup, because we don't recommend using snapshots in this scenario, although we do show snapshots, but those are RDS snapshots, which are different than doing EBS snapshots.
Now let's go a little deeper in a more detailed architecture. We are actually going to look into a highly available architecture. So this is not very different from how you would do on-prem if you are going to set up HA for your own instances. The difference here is we have something called availability zone, multiple availability zones. Whereas when you do your own HA for your production environment, you are going to do in one data center, the same place, right? So if the data center gets struck by lightning, your HA doesn't really help you. You switch over to DR, right? Whereas on AWS, I told you we have 9 regions across the globe, and each region is again subdivided into multiple availability zones. And each availability zone is a collection of data centers, one or more. And whatever happens in one availability zone, the way the availability zones are designed, they don't share anything. So if something happens to one availability zone, if there's a power problem in one availability zone, or there's a networking problem on one availability zone, that doesn't affect the other availability zone. So these are some of the things that we recommend you consider when you do architecture. Because when you are actually migrating your application to AWS, you can just take it and run it exactly as it is on AWS in a single availability zone, but that wouldn't be really leveraging the capabilities that we are providing, right? So you can take care of a lot of these things, leverage the capabilities of AWS quite a bit without changing a whole lot in your existing architecture. So Tom will talk much more about the kind of like phase migration that we recommend people do, lift and shift, then optimizing, embracing, and all those different phases. But even in the lift and shift, where you are just taking your existing applications and moving into AWS, there's a lot that you can do to re-architect it a little bit without being destructive, without spending a lot of money and time, and really leverage the capabilities of AWS. So in this case, we are using 2 availability zones. We have a primary availability zone and a secondary availability zone, all in the same region. And within the and you can see outside the availability zone, all this stuff, the whole thing is within the VPC. Remember our first slide of the 4? VPC. So everything is in VPC. Now within VPC, within each availability zone, I'm creating 3 subnets. I have 2 public subnets, and 2 private subnets and a public subnet. So whatever you have in private subnets can be accessed only by other applications or instances running within the same VPC. Nothing from outside can access what is in a private subnet. So this is kind of like using, or I would say this is slightly the next step, or better than using the double firewall, right? In a normal enterprise configuration, you'll have a firewall, you'll have application servers, then you'll have another firewall, and then have the database servers. And you make sure only the application server can access the database, nothing else can access the database. So everything else that needs data needs to go through the application server. The concept is very similar here. So we have private subnet and public subnets. You will put your database in the private subnet, and you will put your application servers in the private subnet, and you'll put your web servers in the public subnet. So whenever somebody needs to access an application, they go to the web server in the public subnet. The web server accesses the application server. The application server, in turn, accesses the database server. Now we have all this lined up in one availability zone. Just to have high availability, what we'll do is we'll replicate the same setup in the other availability zone. So now we have the exact same thing replicated, a mirror image. We have another database in the other availability zone, a 2 application server, and another web server. So this architecture I put together actually for Oracle eBusiness Suite. So that's why you see a concurrent server there. If you are using like SAP, you are not going to see a concurrent server, it'll be something else. But the plan for architecture for most of these enterprise applications is the same. They are either a 3-tier or 4-tier application architecture, right? Now you can see, though we have 2 databases, we are using only 1 database at a time. You cannot really use 2 databases, right? So we have 1 database that is being used by now 2 application servers, 2 concurrent servers, and 2 web servers. And what we are using the other database is as a standby. So we are replicating data to the other database server using Oracle Data Guard or Oracle Active Data Guard, so the data stays in sync, and the database is available in case something happens to your primary database. Now we hook this all up to an ELB in the front, Elastic Load Balancer, so when people come through to access the web server, because we have this distributed across 2 availability zones, they can be redirected to, based on the policy that you set up, one or the other web servers, right? Now, so this is kind of like the very basic of this architecture, like what Tom said, showed you, would be just the first part of it, right? In one availability zone. Now we are replicating it, we are mirroring the whole thing to a second availability zone to make it highly available. And now we can go to each one of these levels and make it even more highly available, right? Now what I'm doing here is I'm setting up what is called a NAT instance, so your application server and the database server and all this can actually access the internet or access things outside for patches and things of that nature. So now nobody can go through NAT to reach the database server, but the database server can go out to get whatever it needs to get from outside. Then the next step, what I'm doing is setting up a S3 bucket for backing up the database. So in this case, I'm using the OSB that I told you about before, Oracle Secure Backup Cloud Module, plus RMAN to back up the database into S3. So here, see what I did. I actually switched from 1 web server to 2 web servers. So as your load goes up, you can, there's many things that you can do in each one of these planes. Database, you can scale up the database size, you can increase the number of web servers, or you can increase the number of application servers. This could be discrete. And many of these applications are user-based applications. For example, if you take this Oracle eBusiness Suite scenario, there are 2 kind of licenses involved here. One is the database license, which is licensed by number of cores. So you want to make sure you are, sticking to what are the kind of license you have. If you have a 32-core license, make sure you are running your database on a 32-core machine or instance, right? Whereas when it comes to the rest of it, it's all based on number of users you have license for, not number of cores. So you can run it 1 instance or 3 instances or 5 instances depending on your load, right? Which is, I don't think anybody would have done something like this before. One of the scenarios that I have come across many, many times working on these enterprise implementations is once a month, couple of days a month, people are all pulling their hair out. When when you're running payroll at the end of the month, you have your month-end closing as well as payroll to run. Now, you still have the same infrastructure that was there a week ago, right? Now everything comes down and everything is low. People are complaining. You are not sure if the payroll is going to be done or not. So if you are going to follow this architecture, what you can do is for the last 3 days of the month, you add 2 more application servers or 3 more web servers, so you have more capacity to do your processing without without having any impact on your licensing. Or like what Tom showed you earlier, you can set up auto scaling. So now what I've done is earlier we have specific number of servers in each place. We have 2 application servers, 2 web servers, and then I'm going to move to an auto scale group. So and you can set up if the CPU is loaded this much, add another instance. So So that was the complete architecture. This is specifically for the database. And we talked about, one of the things that, or two of the things that I told you or showed you in those 4 slides are here. Can somebody tell me, what is the first one? VPC. What is the second one? PIOps. So good eyes. So we have VPC here, we have PIOps here. And you see the PIOps are, those volumes are striped, right? So those are striped to give you better IOPS. So now I have 3 volumes there, 4,000 IOPS each striped together, giving you 12,000 IOPS. And one other thing you see here is in this architecture specifically for database, I actually not just have high availability with 2 instances replicated using Active Data Guard, I also have a DR architecture in a different region. So you are again replicating data over to your DR database using Data Guard or Golden Gate or Active Data Guard, whatever you choose, and just keep that database and scale up as you need.
All right. Thanks, Abdul. I'm looking at the clock. I think we got 8 minutes. I got 15 slides, so I'm going to seize control.
All right, go
and
ahead.
I'm going to go. So hold on. All right. So the one point on this slide is that you probably don't do migrations and you don't want to be in the migration business. So I'm going to show you some tools. I'm going to show you some services. I'm going to show you ways to get around that. What I find, having done migrations for a long time, is that also people, it's not about technology. It's mostly about project plans and the fact that people don't want to change. So what do you want to migrate first? Other than the fact that you probably want to migrate DR, backup and recovery, like Abdul was talking about, test dev type scenarios. Good candidates are applications that stand alone. A lot of times PeopleSoft, COTS applications do stand alone. They might integrate. Older eBusiness suite applications use things like database links, calling out to remote procedure calls to store procedures in other databases. Those aren't really good things to move, right? Database links have really horrible performance. Calling out RPCs between databases are not good. So if you have integration, make sure it's SOA REST-based integration, not integration at the database level. All right, proof of concept. Almost all of our situations, and this is actually different than sort of legacy vendors, is that we almost always do a proof of concept. We're not afraid of doing a proof of concepts. It's pretty easy to do proof of concepts on AWS. You don't need to acquire any hardware. You don't need to go out there and acquire a lot of licenses, especially when you're talking about Oracle. So it's easy to do a proof of concept. We love to do proof of concepts. So migrating data. Contrary to popular belief is that you don't need a direct connect connection. I mean, Abdul might tell you that you need direct connect because he likes direct connect. But you don't necessarily need direct connect because things like, in fact, some of the I don't know if you've seen it, technologies like Whitewater from Riverbed, they actually do WAN optimization. So although you're going over the internet, and if you can go over a VPN connection to make it secure, you can do 3 to 5 terabytes in, I think, an hour, they specified lately. So you can do it really fast because they do compression, deduplication, make it do really fast. If, in fact, you're saying that, well, maybe I don't want to buy a storage gateway, although storage gateway isn't that expensive, we can do about, I believe, up to about 5 terabytes a day in storage gateway. If you want faster, then you'd go to something like Riverbed. If you're not comfortable with that option, you can always use FedEx, import-export. In fact, the case study I'll show you at the end of it, they decided to use import-export. But don't be afraid of the fact that moving data, large amounts of data, over the internet is possible. The other thing, database replication, you can use things like Golden Gate DB Visit. It's a third party. If, in fact, you want to do failover, right? Because when you do your production move, you want to test that maybe for a week or two. So you want to synchronize the data between the two. You can use something like Golden Gate or DB Visit to do that. All right, forklift, lift and shift. For those people that have been around for a long time, Micro Focus coined the term lift and shift. Micro Focus is old COBOL stuff. But what that basically means is that you take the same CPUs, so you map your processor counts into vCPUs, so into our vPCUs, and you say that's what I'm going to use. You map like web server to web server, app server to app server. You don't use any of our technology, perhaps. You use your F5 load balancer. If you want to embrace, then you start using some of our technology. What embrace means, though, is you don't want to do intrusive stuff. You don't want to do stuff that impacts your architecture. You want to use stuff like ELB that doesn't impact changes. You wouldn't want to move, say, if you had a clustered file system. We don't support a clustered file system on AWS. You wouldn't want to move that to, say, like S3, because that's actually intrusive into your application, right? And then optimize, you want to take advantage of things that we offer. So DNS type services, or moving more to like OpsWorks, CloudFormation. You could probably use that in the embrace phase, but the optimize is actually taking low-level optimization, maybe parallelizing your system, maybe using SQS, things like that, where you might not have to make changes to your application. All right, so I think this is a big one. For me personally, when you're talking about doing migrations, if someone comes to you and says, we have a tool that can migrate your systems 100%, you walk away. If they have a tool that can migrate your systems 90%, I would walk away. If they have a tool that says they can migrate your systems about 80%, I would say, maybe, talk to me. There's no systems out there that can do automated migrations 100% or even 80%. There are tools out there, and if you're talking about like data migration, that's schema, that's data. There are tools that can do it close to 90%. You still might have to do some changes. One of the first ones, if you go from the left here, is application portfolio analysis. This is where you figure out, what do I have? A lot of enterprises don't even know the systems they have. I was talking to an enterprise customer recently that has 4,000 applications. That's not a lot of applications for an enterprise, really. And they don't know what they have. So there's some companies out there, Blue Phoenix, Cast Software, Micro Focus, TSRI is a company up in Seattle that does that. Code migration. So if you want to migrate code while you're moving to the cloud, so say you have a lot of legacy COBOL code, or even Power Builder is legacy code, Oracle Forms, PL SQL. Say if you want to migrate Oracle PL SQL into Java, there's companies out there that do that. iSpire, TSRI are a couple of companies. Data migration services, here's a couple of companies that I've worked with in the past, Mlogica, PacTrans. Data Strategies does tape migration, so if you have a lot of tape, you can migrate those. And then for ERP systems, we have specific partners that we work with that are familiar with those ERP systems. You can see the ones up there, like Apps Associates for Oracle eBusiness Suite, PeopleSoft, DLZP, a back office for SAP. And then there's AWS-specific ones, Cloud Technology Partners. They have a booth here. Raceme has a booth here as well. What they do is Cloud Technology Partners does application portfolio analysis, but they do micro-analysis on your code to tell you what code might not move over to AWS very well because it has things like IP addresses in the code, fixed IP addresses that you probably want to move out into configuration files. So it's a great tool, and it also will take a look at your code and see patterns where it says, well, maybe SQS could be used here, maybe ELB could be used here. So that's very specific to AWS. They have a set of rules. And then if you wanted to just move, we have our import-export facility for VM, right, for VMware. But Raceme can do bare metal migration, so they can read the raw disks, whatever code you have in your systems, and push that over into the cloud. Or they can migrate things like hypervisors from Microsoft, because we don't support that, or VMware type instances. So if you're a virtualized platform, you can take a look at something like Raceme, or you can migrate the bits over from your appliances. Here's some other ones. The question I often get asked is when I move into the cloud, what am I going to use for management and monitoring? Obviously, you could use CloudWatch from us, but you can use like things like BMC, HP, CA, all these vendors that people use on-premise have connectors and will work with AWS. So the idea here is that we're creating an ecosystem so that people that are moving from on-premise are familiar with those tools that they use on-premise when they're inside of AWS. Auditing and logging is the one that comes up often. I created this slide before CloudTrail came out, right? You could use CloudTrail, but here's some vendors that we've worked with in the past. Exedium, Trend Micro, CloudCheckr, they all have auditing and logging capabilities, as well as CA. So if you're using CA for management and monitoring, you could use them for auditing and logging. And then data migration. Here's Attitude CloudBeam. They allow you to beam stuff, if you will, or move stuff in parallel, deduplication, compression from on-prem into S3. You could use things like Tsunami, and I mentioned Whitewater Riverbed already. And then for backup and recovery, a lot of people choose to use things like Commvault, CA that they're familiar with on-premise as well. Like I said, you typically don't want to use snapshots. You can use EBS snapshots. They're listed there down below. But you probably want to use one of those enterprise solutions. And then cost management. Cloud Health is a company. I mentioned reserved instances, that when you're using your TCO, you probably want to look at reserved instances. But when you first set up your environment, you probably want to go with on-demand instances. So you're going to be running on demand for, say, the first 6 months. You want to figure out what should I purchase for reserved instances. Cloud Health can go into your environment and say, based on your usage patterns, this is what the reserved instance purchase that you should make. So you can minimize your risk by getting up and running with on-demand, and then use a tool like Cloud Health to figure how much reserved instance purchase I should make. Apptio is a company I mentioned, TCO. They do TCO analysis to figure out, if you have a huge portfolio of applications, what's going to be my TCO. All right. How much time do I have?
You have enough time. Go ahead.
All right. Let me do this real quick. Here's the customer success story.
People still want to know, so you don't need to do quick.
Oh, no, I can do it quick and they can still know. So what they did this for is vendor consolidation. They did infrastructure management across different locations. I'm going to tell you how many locations they had. And hardware refresh and cost optimization. So for those people that are doing like a hardware refresh, perfect time. Like these folks were doing a hardware refresh, a perfect time to move to AWS. So these are some of the benefits that they received. 55% reduction in operating costs, 35% reduction in infrastructure cost. You can see they got down from 6 vendors to 3 vendors. And they were able to perform an office relocation. I mean, obviously, when they had hardware and on-premise, it's hard to move an office, right? But if your systems are all running in the cloud, it's pretty much easy to move an office, right? And obviously, they take advantage of the stuff like test, dev, QA. They shut that down on the weekends when they're not using it. So this is what they did. Pretty classic scenario here for what we find people doing is obviously they did an assessment. They worked with a partner that I mentioned earlier, because this was an eBusiness suite migration as well as a SQL Server, Oracle Business Intelligence suite. So it was a data warehouse. It was using eBusiness suite as well as SQL Server. And they did an assessment, a proof of concept. They moved non-mission critical apps, test and dev. And then they moved the eBusiness Suite application in OBIEE, which is a business intelligence application, data warehouse, over to AWS. And this is a pretty simplified version of the architecture, but essentially they have 2 locations. They're not using DirectX, they are using VPN. They're using actually OpenVPN. So for those people that aren't familiar, instead of using our customer gateway, along with our virtual private gateway to do a VPN connection, you can use OpenVPN. So that is an option. Some enterprise customers don't feel comfortable with like open source software, but in this case they are using OpenVPN to make that VPN connection in. And then have a private subnet for the OBIE and the eBusiness Suite, and a public subnet for those people connecting in from the second location. So here's the infrastructure. Another thing I wanted to point out on this is that they moved, how they sold this to upper management is actually just on reducing a lot of their tape costs. So they were doing tape backups, and they moved that into S3 and Glacier using Zamanda, one of our partners as well, that can back up into S3. The other thing that they're doing is that actually their Active Directory server, they still have one at all those locations I talked about. So, but the main Active Directory server is inside of our infrastructure. So they synchronize between those other locations, right? So if there's a change in one location, it gets synchronized into AWS and it gets pushed out into the other locations. They also use Active Directory with Salesforce. So they use the Active Directory that's in AWS to authenticate against Salesforce as well. And then all production backups are into S3. And the interesting thing here is non-production backups are into reduced redundancy storage S3 because it's more than sufficient. So another way to keep track of, I don't know if you remember earlier in the presentation where I talked about using tiered storage. Here's where there's no reason, because actually we never lost anything in S3, I don't think. But reduced redundancy storage is cheaper, and if you have non-production workloads, easy to move your backups into there. So thank you for attending. Please fill out the survey. This year was the first year where we had enterprise presentations. We want to make sure that the enterprise presentations are hitting the mark so that next year we can make them even better. So do please fill out the survey. And also look for reference implementations to come out in the new year in 2014 around SAP, Oracle, and Microsoft. We're going to be producing with partners a number of reference implementations around SAP and Oracle, around eBusiness Suite, PeopleSoft. So look out for those on our website. Appreciate you coming. And if you have any additional questions, please come visit us.